Hi guys, welcome to this video, and in this video I'm going to talk about trace of a matrix. So first of all, let me write it down. So trace of a matrix. So what do I mean by trace of a matrix? Well, it's a fairly simple concept. So let's say that I have a matrix. I have a square matrix here, which is something like this. So let's say let's take a general matrix. So A11, A12, A13, and then A21, A22, A23, and then finally we have the third row, A31, A32, and then A33. So this is my 3 cross 3 square matrix. Now trace is nothing but just the sum of all the diagonal elements, and by diagonal elements I obviously mean these elements. So these are the elements that belong to the diagonal, also known as the left diagonal, and it's also called as the principal diagonal. So if you sum them up, if you add them up, you will get trace of, so let me label this as matrix A. So trace of matrix A is nothing but sum of all the elements. So we can also write it like this: from I is equal to 0 to n aii, because if you recall, all the elements in the principal diagonal can be represented by aii, because the row and the column that they are in are basically the same. This is the element in the first row in the first column, this is the element in the second row in the second column. In the same way, this is the element in the third row and third column. So we can write trace of A as this, and we can, for this example, it's going to be equal to A11 plus A22 plus A33. So hopefully now you understand what a trace of a matrix is, even though it's a very fancy word, but the concept is pretty simple. Now I want to talk about one example. Let me see if I can write that example here. And one thing to note is that trace of a matrix is only defined for a square matrix. So if we have a matrix which is not a square matrix, then we cannot define the trace of that matrix. Alright, now let me jump to the example. So it's a 4 cross 4 matrix. So let me try to draw it. X minus 1. So I'm constructing the first row, 0, 2 and 5, and then I have 3 x square minus 2, 4, 1, and then minus 1, minus 2, x minus 3, and 1, and then finally 2, 0, 4, and x square minus 6. So this is the matrix, and the condition is that trace of the matrix A, so let's call this A, trace of this matrix A is equal to 0, and then we have to calculate x. So what x can be? So first of all, what is trace? Well, trace is just the sum of all these diagonal elements here. So all these elements which are in terms of the variable x, if we add them up and we equate them to the 0, because it's given that trace of this matrix is 0. So let's do that actually. X minus 1 plus x square minus 2 plus x minus 3 plus x square minus 6 is equal to 0, right, according to the given condition in the problem. And now we can just simplify this a little bit further. This is going to be equal to 2x square, and let's group all the x's together. So it's going to be x, so it's 2x, and then let's group all the constants together. So it's going to be -3, -6 and -12, right? So yeah, -12 is equal to 0. Now this is just a simple quadratic equation, and we can just divide both sides by 2. So it's going to be x squared plus x minus 6 is equal to 0. Now you can just guess by looking at this equation that the two roots are 2 and 3, not 2 and 3. It's actually -3 and 2. So -3 and 2, and you can actually just like guess it, or you can factorize this equation and arrive at this conclusion. And you in order to verify, you can just see that the sum of the roots, which is equal to -1, is the negative coefficient of x, and the product of roots is -6. So it's a way for verification. So there you go. So x can be -3 and 2, and if x is -3 and 2, and you put this into this matrix A, you will be given the trace of the matrix as A. So if you calculate the trace of the matrix when you input -3 and 2 as x, then the trace of this matrix is going to be 0. So thanks for watching this video. I'll do more videos on matrices and determinants, and if you want to request a specific video, please let me know in the comment section below. Thanks for watching.